you are in good health. Today, our lesson is about rate of change. But what is the rate of change? And what is the relation between rate of change and our daily life? Let's check it out. Now, we know how the rate of change relates to our life. So, it is important to know how quickly or slowly these changes are taking place. That's why we need to know how to calculate or measure the rate of change. Let's try this.
Before we proceed with the solution to the rate of change, it is better to recall the strategies that we need to take for solving and calculating any related rates problem. First, draw a picture of the physical situation and assign letters to all quantities. For example, we write radius as r, time as t, volume as v. Second strategy, identify the rate of change that are known and the rate of change is to be found. Usually, a rate is expressed as a derivative and respect to time. Third strategy is write an equation that relates the quantities of interest. Next, differentiate both sides with respect to time. And finally, substitute all the given values and solve the problem. Let's use on problem-solving strategies to answer the next question.
Example 1. The radius of a spherical balloon is decreasing at the rate of 2 cm per minute. Find the rate at which the volume of the balloon is changing when the radius is 5 cm. Give your answer in terms of pi. Since the problem is simple, so you no need to sketch the situation. You proceed by labeling the given quantities, which we write r equal to radius of balloon and v equal to volume of balloon. For the second step, we identify the given rate and also the rate that we need to find. We are given the radius of a spherical balloon is decreasing at the rate of 2 cm per minute. Means the radius change at the rate dr dt equal to -2. Notice that we have to make the rate negative to capture that the radius is decreasing. We also given radius equal to 5 and we write as r equal to 5. Question asks us to find the rate at which the volume of the balloon is changing, and this can be written as dv dt. So now, all the information provided is recorded. We proceed with step 3, which we write the spherical volume equation, that is V equal to 4 over 3 pi r cubed. Since V is in terms of r, we can differentiate V with respect to r and obtain dV dr equal to 4 over 3 pi times 3r squared. And simplify, we get 4 pi r squared. Next, for the fourth step, we develop the relationship between the rate we want to find and the rate that we have by applying the chain rule. Then we obtain dV dt equal to dV dr times dr dt. Now, we substitute dV dr by 4 pi r squared and dRdt by -2 and obtain dVdt equal to -8 pi r squared. Hence, we calculate dVdt by substituting r equal to 5. And the value of dVdt is -200 pi. Lastly, we write a statement as follows. Thus, the volume of the balloon is decreasing at the rate of 200 pi cm³ per minute. Now, we will proceed with the second example. Read the question and try to extract the information. Two cars start from a common point P at the same time. Car X is travelling east at the rate of 100 km per hour and car Y is travelling south at the rate of 105 km per hour as shown in the diagram. Obtain an equation that describes the rate of change of the distance between two cars. Hence, evaluate the rate of change of the distance between the two cars when car X is 0.2 km and car Y is 0.21 km from P. Since you are given the diagram, so you just write down the numerical information. In the diagram, X represents the distance driven by car X and Y represents the distance driven by car Y. And we let U as the distance between two cars. Next step, identify the known and unknown rate. We are given the rate of car X is 100 km per hour. And this can be written as dxdt equal to 100. And for car Y, it is dydt equal to 105. We are also given the distance of car X and car Y. They are X equal to 0.2 and Y equal to 0.21. The question asks us to find the rate of change of the distance between the two cars. And this can be written as du dt. Once all the information has been written, then we can proceed with the next step. Refer to the diagram. The diagram shows a right angle triangle. And this we can relate with the Pythagorean theorem. Then we express the situation as u squared equal to x squared plus y squared. Now, we differentiate both sides of the equation with respect to time by using implicit differentiation and obtain 2u times du dt equal to 2x times dx dt plus 2y times dy dt and express du dt equal to 1 over u times bracket x times dx dt plus y times dy dt. If we refer to the known values, we have dx dt, dy dt, and values of x and y. But we don't have value of u. So, for the fifth step, we need to find u by substituting values of x and y into our original Pythagorean statement and get u equal to 0.29. Finally, we plug in all the known values into du dt and solve it. The values of du dt is 145 and we write the statement as thus the rate of change of the distance between the two cars is 145 km per hour. Finish our lesson today. See you again.